हेलो 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 हेलो
I request all the participants, particularly student friends,
Check.
you can call to your friends inside this auditorium because within few minutes we are going to start the first session of this Energy Conclave 2022. So I request everyone,
They can occupy the front seats.
yeah, I request all the participants, particularly backbenchers, you should come forward. You have to fill up the first row, first and second row. Come on fast. कोणाचा असेल फोन येईल ते. Yes, thank you. Back students, please come forward. All the coming session are very informative and fruitful as far as engineering student is concerned. So I request everyone to come inside this auditorium to attend this expert session.
Mic off. No.
A hearty and warm good afternoon to one and all present over here. On behalf of CSMS's Chhatrapati Shahu College of Engineering, I, Ms. Dipti Gunjar,
And I, Mr. Tejas Pawar,
welcomes you all for this session.
after the wonderful inaugural ceremony, we have assembled over here for an interactive session on the topic of hydrogen fuel cell. As we all know that the world is migrating to electric vehicles and electric vehicles run on the lithium ion. All of us know that there are tremendous efforts have been put to find alternator to lithium ion batteries. Guys, do you know about that alternator? Anyone? No? Okay. It's nothing but the hydrogen. Now, friends, do you know the name of first hydrogen fuel cell car in India? I repeat the question. Friends, do you know the name of first hydrogen fuel car in India? The hint is our Honorable Union Transport Minister Nitin Gadkari ji used that fuel car in January. So anyone can answer? No, okay. Its name is Mirai. Mirai, which means the future, developed by Toyota. Now, this session topic is hydrogen fuel cells, which will be shortly delivered by our prominent speaker, Dr. S.A. Yogesha, Senior Manager, Fuel Sales, Bosch Limited, Bangalore, India. Now, I would like to request our session coordinator, Dr. R.P. Deshpande, scientist, author, technical consultant in the field of electrocapacitor and fuel cells, to bring our prominent speaker, Dr. S.A. Yogesha, on the dais.
Now, before I invite Dr. S.A. Yogesha sir for his talk, let me take this opportunity to introduce our prominent guest. Dr. S.A. Yogesha has completed his PhD in development of fuel cell stack and fuel cell system modeling from IIT Bombay. Also, he has completed MS and BE in mechanical engineering. Dr. S.A. Yogesha has an overall experience of 12 years in hydrogen fuel storage and fuel cell technologies. Sir also has employed with Tata Motors and Reliance Industries. He has published 10 patents in FCEV field. He has 5 international journal papers in FCEV field, technical assessment of consulting partners, development of hydrogen storage system, testing and integration in the vehicles, developed fuel cell power system requirement specifications from the base, design of BOP components and though validations on bench level, involved in future e-mobility roadmap and deciding development strategy, key BOP components.
Now, I would like to request our session coordinator, Dr. R.P. Deshpande, to kindly felicitate our prominent speaker, Dr. S.A. Yogesha. So, with this brief introduction of our today's chief guest, now I would like to request Dr. R.P. Deshpande to please kick off the session on the topic of hydrogen fuel cells.
Sir, please.
Sir, please.
It's in a good spirit that we are starting this first session with a future technology. We all heard about fuel cell quite a bit, but people are not very clear about fuel cells. They have made a significant entry into the vehicle segment, and today we look at hydrogen as a major source of energy. Hydrogen as such, it is getting an importance not just for vehicles, but even for large-scale stationary energy storage. Energy density of hydrogen is very high compared to even batteries or any other source of energy. And the big benefit is it can be stored for a long, long period, a couple of months or maybe more, but without any loss. Another beauty with hydrogen is it is being used in, apart from energy, it is already being used in several industries even now. Green hydrogen, or the eco-friendly hydrogen produced from water, it is much more eco-friendly compared to any other source. And there is a possibility, or even whatever the work is going on, if hydrogen is produced from waste, you even have a negative carbon footprint. That means you help reducing the existing pollution as well. And today, hydrogen is looked upon as a future's oil, as we can call it, and today we speak about hydrogen economy. A number of people, number of countries are looking to hydrogen and fuel cells more than the batteries. And even though today it's a bit costlier, but in the very short, maybe 2-3 years, maybe it will become cheaper than the batteries as well. It will be much cheaper to use fuel cells rather than anything else. Today already you have heavy vehicles, trucks and buses running on hydrogen and there are a couple of models of cars also in the market. Not just that, today we find even 3-wheelers and even 2-wheelers running on hydrogen. That is going to come to India in the due course of time, And we will look after this, we are looking after the fuel cell technology with a very promising future. I know you are all very much eager to listen to the eminent speaker, and who has come a long way, and he has got a long experience in the technology. So, without taking any more time, I should have to hand over the baton to Dr. Yogesha. Thank you. Thank you.
Thank you, sir.
Now I would like to request Dr. S. A. Yogesha to start his session.
Please, sir.
Please, sir.
It's fine. It's fine. Can you just... thank you. Sorry for being very high, so difficult to... Yeah, very good afternoon, everyone. I understand after about like listening 2 hours from morning, it's very difficult to sit here. So I don't get bored, don't worry. I am going to talk about something more or less on what you can understand and where you can play a role as an engineer. Because we talk about everyday technology, innovations, and lot of disruption in the part of market. But how to prepare for that actually? So hopefully I think Energy Conclave 2022 organized by CMI especially on this topic on energy, EV, and hydrogen fuel cells make some sort of like beginning for you what I can just put my efforts after my engineering. Because I think post-engineering, you're going to put print on industry, or else, as one of speaker was talking about, you can start your own industry as well. So the fuel cell makes some sort of interesting topic if you want to start your own industry as well. Because as a technology is coming up very, very, very nascent stage at this moment. So I think if you know something better than someone else, obviously you can make contribution towards on this technology, and also you can just start looking in terms of like what I can just do in terms of innovation part of it. So let me start my session with my contents. Basically, I'm not going to talk about too much on basically on the, say, more on IFI things. So I'm going to keep it very basic stuff so that you can understand. And then you can ask me a lot of questions at the end of session so that I can answer all your questions. So let us be interactive so that actually you will also get benefited, and also whatever I'm explaining, so I'll be okay with that actually. Because otherwise it's more or less I'm going to talk and you're not going to understand anything. So I don't want that to be happen for you. Okay, so I'm going to brief about on the introduction about like this technology. Why this really technology is there? Because many people are talking about EV, and also hydrogen IC engine is already available because petrol, diesel vehicles are running. So why you want really hydrogen fuel cells? Whether it's going to make substitute for any fuels, let us look into that part actually. And then it's working principle, because any technology comes, it's having different type of working principles, right? So here actually I'm going to talk about brief about on working principles, how it works, and types, design of performance parameters, and what are the benefits it's going to give us in terms of comparatively you're having fossil fuels. Because as I said, diesel, petrol, CNG, everything is available. How does it make sense? So that's we'll talk about on that part. And applications, really it's having very, very good applications, or else it's just only for a sake of what you call actually in the books. So that I'm also going to talk about it, because many peoples in the world already put a lot of efforts towards this technology, and they made it what you call actually the practically possible. Okay. Only thing is few technology disruption has to happen in this part of
fuel cells that has to go via only understanding this technology, broadening the team, and also understanding more into the fundamentals aspects. That I'm going to talk about, and especially hydrogen. When we say hydrogen, safety. Safety is more important because hydrogen is such a molecular, lighter fuel, which is like odorless, colorless, and we should be very careful in terms of safety requirements. So I'm going to talk about on safety requirements as well. And then finally, what is potential fuel cell application in India? Because what we are talking about in other countries, but what about in India? Because whatever is happening in outside of India, same thing will not be applicable in India because we have a different environments, different ambient conditions, which has to meet or else meet specific to the region specific. So that's why we called what exactly the application would apply, especially to the hydrogen fuel cells. Sorry. Oh, that's fine. I can. Okay, so I think from morning onwards we are hearing like, do I'm audible? Is it okay, friends? Okay, great. So today, like morning onwards we are hearing like lot of pollution, global warming issues. So today, talk about like 2021, we have produced 2.88 billion metric tons of CO2. Can you believe it? So majorly contribution from power sectors and transportation sectors. You can imagine 2.88 billion metric tons of CO2. So that's the reason you could see in Delhi odd and even numbers and banning UI because CO2 emission. So obviously you look forward for alternative fuels. Yes, EV is the solution. Let us look into that part as well, whether EV makes sense or hydrogen fuel cells makes, or else both are complementary to the existing hydrogen ICE engine vehicles. We'll look into that part. And as part of like say, we have imported $119.1 billion of crude oils in 2020, you can imagine. So every year we are going to import this much billion dollars. It's huge, right? So obviously we need to look forward like what is the alternative fuels, or else what you call actually what is the alternative fuel you can encourage towards going into the greener technology and also encouraging avoiding fossil fuels, because every oil we are importing today, so it is not available in India. So that's the reason you could see that lot of investment towards on hydrogen, especially Ambani, Adani, more or less they are planning to invest 65,000 crore investment in India, especially Ambani alone. It's huge. Why they are investing? They're seeing the more potential towards this technology. It makes viable once it goes to the scale part of it. What is scale exactly? Once it goes to the production basically. So what we are seeing today is basically on the R&D, more or less in a very low scale volume, but not into the higher scale volume. But once it goes to the scale, obviously it makes sense. And also as part of COP26, like that's basically the ambitious commitment climate summit, where actually India is pledged basically to reduce 1 billion tons of CO2 by 2030. So to meet that, obviously you need to look for alternative fuels, or else you're going to end up with like say that only you're using fossil fuels. You know that today diesel and petrol price more or less crashed 100 rupees. So about like say 10 years, it's about like say not even half of the price. So after 10 years, you can imagine what would be the price of petrol and diesels. And not only price, what I'm talking about even global warming as well. So CO2 percentage also is going to increase because whatever we are getting from environment, and also we need to give back to the environment as well to protect our environment. Otherwise, in a longer run, like not in this generation, next to next generation will not be available any fuels to use it actually. So obviously you need to look forward what is alternative for it. So that's the reason hydrogen fuel cells make sense over here. So what is hydrogen really? So what we are saying that hydrogen fuel for the future. So every day you drink water, right? So I can say that, right? So if I use water as a fuel, how does it make sense? Does it make sense? So what I'll do, I'll take the water, I'll do electrolysis process, I'll split into because it contains what? H2O. So I'll easily split 2 molecules of hydrogen and 1 molecule of oxygen. So I'll use simple process called electrolysis process. I'll split the hydrogen, and then that hydrogen I'll store it in terms of compressed storage or cryogenic or liquefaction form. So I got a fuel now. So friends, you don't think it is very interesting now? So hopefully I think so. I can understand, I think most of people are coming out of coffee break. So take some easy notes so that it would be useful for your in future where you want to go about your like in your after engineering or else you want to break something on the technology or else innovation part. This will make easy for you. So what I said basically the hydrogen is available via electrolysis process. I'm saying only one process. I'll talk about on the more also how hydrogen will be produced. So, still it's not audible. Great, thanks again. So now hydrogen we can make it via electrolysis process, but many process we can make it. Like say we have hydrogen production from many technology like steam methane reforming and other things. Those are all produce even CO2 as well. That's why I'm not going to talk about on that part. Later point of the time I'll introduce those technologies as well. But to talk about on the top level, you have a source of renewable energy, because why government is encouraging towards on renewable energy? Because you produce electricity, but you don't have storage. EV in same day you cannot use it, right? You need to store that energy. So this will act as a storage for you, because as a oil, diesel, petrol or gasoline you can store, right? Hydrogen also can be stored in any form. So once you produce electricity, because you know that solar or renewable energy is available only for a 20% of the year, not exactly complete year, because hardly we have a 20% of solar energy is available. But that alone you cannot use it for your EV electric vehicles, right? So you have a sort of issues via like demand and supply issues, right? So that's what everyone was talking about morning today, like EV we have a sort of like supply of energy, which is coming from coal or else your common fuels. So that's the reason I said that I'll use the renewable energy to produce hydrogen. Okay, so that I'll split via electrolysis process to produce hydrogen. I'll store that hydrogen in terms of any format, like as I said, that compressed storage or else liquefaction or else cryogenic. So I got a fuel now. So what I'll do with that fuel now? So because EV you have electricity, you can feed into the battery. Battery will store the energy and deliver the electricity to run your motor in the vehicle, right? But here it is not the case, because you have a gas or else fuel as a hydrogen now. So now I need to use that fuel into the hydrogen fuel cells. That's what I say, that next is hydrogen fuel cells. So what I'll do, I'll just use it in two ways. Two multiple applications are coming up nowadays. Hydrogen ICE engine as well. What people will do, they directly feed hydrogen itself in ICE engine after a few modification in the ICE engine. And second part is hydrogen fuel cells. Fuel cells, what it does, similar electrolysis process, but it is reverse now here. So what I do, I feed hydrogen as a fuel, oxygen from atmosphere, I'll produce the electricity. So once I produce the electricity, I'll drive the motor. So you have sorted out all the solution now. So you have the fuel abundantly used as a sort of like water as a source, starting from storage. So what I'm talking about, like well to wheel, if I talk about well to wheel is nothing but starting from generation to usage in the vehicle. So it makes sense, right? Right, my friends. So let us move on to what exactly the application. Hope you got the basic understanding of hydrogen at least, because what I'm going to talk about now on much into the where exactly it fits, because we are saying that actually the hydrogen fuel cells are there and EV also there, right? Because today talk about morals on the energy conclave. So we talk about today on EV. So why? So if you look at EV, more or less, if I talk about on the part of like applications, short distance applications. Short distance is nothing but battery can be stored, and if you look at for small cars applications, or else you can call it as like bike applications, personal vehicles, as Nexon EV is there. You could see that MG Hector is there. So similar vehicle, it's possible to use. The concern, what you're facing today concern? Can anyone tell? because short distance. You are not able to travel longer distance. Why EVs are not popular, not buying many people's? Because battery capacity goes up. You cannot store higher capacity of battery in the vehicle because you have vehicle very less space, right? You cannot package or else place it inside the vehicle all this lithium ion batteries as well. So you have concerns for long distance vehicles. So hybrid vehicles also came because part of like plug-in hybrid vehicles and hybrid vehicles, some part of the footprint fallen here, but in India actually straight away from hydrogen IC engine, it's moved to EV. Plug-in hybrid vehicles and hybrid vehicles are not taken up because that was not giving much attraction towards on CO2 emission as well as giving in terms of like energy benefits. So that's the reason, because if you look at other countries, apart from India, more people were talking about hybrid vehicles, plug-in hybrid vehicles, and also range extended electric vehicles. But in India, it's not given much, what you call actually the preference for hybrid vehicles. Why it is so? Because it was not making huge impact towards on both these things, aspects, as I said. Especially for medium to long distance applications, because as I said that you have a fuel now, you store the fuel as you store in diesel and petrol, and then you can use that fuel to run your vehicle. So that's the reason actually for medium to long distance, especially for heavy duty trucks. Because if you look at nowadays, more or less all transportations coming from like goods transportation and everything, those are all running in diesel. Why they have not moved to EV? Anyone can answer this? Because they cannot package all these bigger batteries, and also the distance. You have issues, concerns. So that is the reason, as I said, that why Ambani or else Adani are investing on this technology. Because for them, every day, petrochemicals, they use more than 200 trucks. You can imagine. Every day, 200 trucks. They cannot pay every day 200 trucks diesel, right? Because the cost is increasing drastically. They are not only making towards on energy sustainable for the country and also their own consumption, basically. So that is the reason every day they can use hydrogen as a primary source, as a fuel. They can use it for in-house consumption. Even though they don't have a market, that's fine for them because they can use it for their own. And also it's basically the emission-free vehicles. So that's the reason you could see that actually the more people are coming towards on hydrogen. So hope you understood that actually for long distance and medium and long distance trucks, buses, and intercity applications, because you need to travel from here to Mumbai or something like that, more distance where it comes like more than 200 to 300 kilometers, fuel cell vehicle makes sense. Because initially, for up to 200 kilometers, you can use the EV vehicles. But more than 200 kilometers, it is not suitable, actually. So I feel that actually where medium or long distance, more than 300 kilometers, you require a range, better to go with the hydrogen fuel cells instead of going with the EVs. And especially, it makes huge impact, right? Basically, when you're going for storage about like say, I say that 30 to 40 kg of hydrogen can drive about like 400, 500 kilometers, that's a huge range for you. And if you make it any refilling station between 500 kilometers, that works for it. So, but especially in EV, the concern is you need a refilling station every 50 or 100 kilometers. So that's where huge problem, huge rush. That's the reason everyone talks about like how to, because morning I think we are hearing one is like chicken and egg story. So where we do not have a EV infrastructure. Obviously, because they cannot invest without EV vehicles. EV vehicles are not coming up because they don't have a EV infrastructure. Because OEMs are not producing because you are not buying it. Or else we are not buying it, right? So obviously it makes sense. So more or less anything transition towards on new technology makes impact. So that's the reason I said that for long distance vehicle, fuel cell makes huge impact actually. I hope I am clear. Sorry, I skipped one slide. Okay. Okay, so I think I'm very clear what I'm talking. I think if you have any questions, you can stop me anytime because as I said that in the beginning itself, I want more to be interactive session instead of like you're not understanding anything, you can stop me anytime. I can explain somewhat in a easier words still because I feel that this technology going to disrupt. And if you're going to work on this technology, it would be future for you. So I feel that if you take it very seriously, you can make your own company as well, own business as well, and also own, like you can join your own companies as I join. Don't talk why you are not started company. Okay, just in a lighter note, I'm just telling, okay? So I think it makes huge impact. That's the reason I'm telling, like if you have any questions, you can stop me in any time because I want more to be interactive session, okay? Guys, clear? Hope I'm not boring. Great, I have one friend to ask question, great, thanks. Sorry, I don't know whether they have mic or not, I can. Yes, you're audible to me. Cover the. Okay, that automatically it covers. Because EV is there already. Why? Because any application you could see that actually you can meet EV already. So the major benefit you'll not get if you make a TCO, we call total cost of ownership. What is total cost of ownership basically? I'll buy the vehicle, I'll run for about like 1 lakh kilometers. So I am giving per kilometer 4 rupees, imagine, for your personal vehicles. Okay, so 1 lakh kilometer multiplied by 4 rupees, about like 4 lakhs. Plus your vehicle cost about like 10 lakhs. 10 plus 4, 14 lakhs rupees. So the difference between diesel or else EV or else fuel cells are slightly different in the range of scales. If I say diesel is about like 1, the EV about like 1.2 to 1.4 times the cost. If hydrogen fuel cells about like 2 now, right now. So once you go for a longer distance applications, especially for trucks and buses, especially why I'm not referring to the personal vehicles, because personal vehicle, whenever you feed it, you just calculate your part of how much money I'm spending for the vehicle as well. So nowadays, today, as I was mentioning, the one of the person as well as speaking, like Toyota Mirai is launched in India. So someone can buy as well. Why people are not buying? Because the cost is not making sense right now today. Okay, because otherwise in the longer run it makes sense, and obviously it covers the shorter distance applications. There's no problem. But shorter distance you cannot compete with the EV because EV is already there. It's available in cheaper cost. Cheaper cost means comparatively the fuel cells. Why you want to go for higher cost? Right? Hope I answered your question. Thanks. Thanks for asking question actually. So I'm happy to answer that question actually. So let us look at the some sort of like properties of hydrogen. Basically it's stored in compressed gases, especially in vehicle. So there are like different types of cylinders will come. You're seeing I think LPG, right? LPG stored in a sort of like type 1 cylinders. So you're seeing the gases also. All are stored in type 1 cylinders. And type 1, type 2 are preferably used for stationary applications. Onboard application is more or less type 3 and type 4 cylinders. What is the difference basically? Why you want to store with a type 3 and type 4? Basically, if you have metal cylinders, embrittlement issues will be coming for hydrogen especially. It can leak through the metal as well as you're storing in higher pressure. That's the reason for onboard application. Why I say onboard? Why not it's stationary? Onboard is nothing but you have vibrations, dynamics, everything impacts. For stationary, nothing will be there. That's the reason you can go ahead with a type 1 or type 2 cylinders. Type 3, you need to go for a composite cylinders. So those are like type 3 and type 4 are made up of type 3 basically aluminum liner wrapped with a fiber reinforced epoxy. So it's basically composite cylinder for your easy understanding. And type 3 and type 4, what is the difference? Type 4 will have, instead of aluminum liner, it will have a plastic liner. That is the major difference. So nowadays, actually, the Toyota Mirai comes with a example, if I want to give type 4 cylinders, which can be stored up to 700 bar pressure. Type 3 are capable of 350 bar pressure. At this moment in India, basically the approving agency is PESO, CCOE, what they give the clearance, they given up to 350 bar storage pressure. Why I'm telling you all these stuffs, better if you just say that hydrogen fuel cells I know, then you should know that how I store the hydrogen. Right, so because someone may ask you that how do you store the hydrogen? So how can you use that hydrogen as a fuel in a compressed form? So that's the reason I'm just giving some hints. And also, as I said, that it's colorless and no odor, and also it's having lighter. In the periodic table you've seen, hydrogen is the first fuel. So you can imagine the power of hydrogen now. So that's the reason, basically, you can just go on into the particularly pastoral things. I just skip other general properties because all are like, you can just see the common properties, which I'm going to talk about. Only I'm going to step up on like upper flammability limit, lower flammability limit. What is exactly upper flammability limit? Upper flammability limit means once it leaks through atmosphere, when it catches the fire actually. Till 75% it catches the fire. In the lower limit of flammability limit, up to 4% it catches the fire. So that's what I mean to say that actually. I'll just quickly move on so that I can understand. I took a lot of time for yours, and then I'll just quickly try to, because I wanted to give you some fundamental aspects of hydrogen fuel cells, then I can just switch over to somewhat in a faster manner so that you can just quickly catch up. So basically there are many sources of hydrogen production process. Basically it is divided into different colors, gray hydrogen and brown hydrogen, green hydrogen, based on what technology they use it. If I use natural gas as a SMR method, steam methane reforming, then it's called as gray hydrogen basically. So basically your input will be again your natural gas. That's the reason more people today, hydrogen is used in not only vehicles, it's used in power sectors, it's used in cement industries, it's used in glass industries, multiple fold of application. All hydrogen today is produced via SMR method. We are not producing via anything on electrolysis. So the second is partial oxidation. That's also basically gray hydrogen. And if I come to the second part of the things, blue hydrogen also will come. So blue hydrogen, what is the difference basically comparatively the what you call actually the gray hydrogen? Blue hydrogen is there, you will capture the carbon as well there. So you can sell that carbon as well. So that's the reason it's called as blue. The last part of things are more or less renewable energy, water electrolysis process, what I was talking about on the hydrogen production process, where you can split the hydrogen into protons and electrons, and then you can just capture the hydrogen as a fuel. That's what I was talking about. Water electrolysis process, all are like green hydrogen production. So I just wanted to give you that what exactly happens in FCE fuel cell inside construction. You have a hydrogen gas because you are feeding as a hydrogen gas via, you have one box called like anode and cathode part of it actually. So there it will be feed as a hydrogen gas that will split the hydrogen in terms of like protons and electrons. That protons will pass through the electrolyte. I understand it's quite difficult to understand. It's similar to the batteries only, not much complicated. But here you're using, instead of what you call electricity, you're producing the electricity here, because there you're storing and then using it actually. Here you're not storing it because your fuel itself available as hydrogen. So then here actually the emission, you can see that pure water vapor actually. There is no emission at all, zero emission. So what you're contributing towards on environment is basically you're making zero emission, and also you're reducing carbon footprint, and you're encouraging towards on renewable energy resources. So this will be in longer run, it's going to impact towards on the greener energy. So what is the difference between the conventional and fuel cells? So basically we'll have a sort of like chemical energy as a fuel, then it will go to the IC engine where internal combustion will happen, and then you have losses of mechanical energy, heat energy, and then it will go to the electrical generator. So if I talk about fuel cells, only electrochemical reaction happens, that's it. Then it will generate the electricity. There's no much losses comparatively hydrogen, sort of like say conventional IC engines. That's the benefit you get it in hydrogen fuel cells. Let us look at the working principles, because what we are talking about today, like more into the fundamental aspects where we said that hydrogen is available, but how that really hydrogen makes. Once you store the hydrogen in storage cylinders, hydrogen will come in a compressed form, and then it will come and touch with a sort of like we call as catalyst layer. Catalyst layer is made up of basically platinum and carbon. So that's where your lot of invention is going on towards on reducing the cost. Basically platinum is costly, right? You can imagine. That's the reason people are trying to find out alternative catalysts which can do the same function as well, like palladium based catalyst. So here actually once hydrogen enters, it will split into the protons and electrons, and protons will pass through the proton exchange membrane, and then electrons pass through the external circuit to produce the electricity. And then come back to the oxygen side, where actually the oxygen reduction reaction happens. Oh, I'm using too many words. Sorry for that, actually. I'm not finding alternative words for these things. So, okay, oxygen reduction reaction happens, and then it produces the water vapor, actually. So it's more or less for you, just imagine in 10th or 12th experiment, you're done with the water where you inserted cathode and anode and you produce the electricity. Somewhat in similar manner, so you can just imagine. And then it's nothing more than that, actually. It's easy process. Only thing is the noble materials costing us. And it's making huge impact towards on the cost part, and also going into the sort of like, going to the commercially viable solution is not making feasible right now today. Hope you got the brief understanding, I feel. Okay, so you can just ask me that what are the different types of fuel cells are available? Because today we have multiple fuel cells like polymer electrolyte membrane fuel cells, that's called proton exchange membrane fuel cells, AFC alkaline fuel cells, and then PAFC phosphoric acid fuel cells, molten carbonate fuel cells, SOFC solid oxide fuel cells. These are the 5 technologies are predominantly used in the globally. So more or less in world, more or less it's used PMFC for vehicle applications to produce electricity to run your vehicle. Why? Because it operates in a very low temperature and also requires sort of like, say, hydrogen as a gas, because in other fuels will work as like it takes some time to start up the vehicle. But hydrogen PMFC application, it will not start up immediately, because you can start up immediately as like comparatively other SOFC or else other fuel cells. That's the reason more dominant technology towards on transportation application is PMFC, polymer electrolyte membrane fuel cells. Why it is called? Because it exchanges the proton in the membrane. That's why it's called proton exchange membrane. So I don't want to go as in deeper, because it acts as like sort of like platinum as a catalyst, as I said that. So that's where it impacts the cost. Otherwise, all are more or less similar to the battery only, cathode and anode materials. Okay. What I talked about, like different types of fuel cells. As I said that PMFC is more dominant. So if I talk about performance, like IC engine also will have a Carnot cycle, right? So it's having some performance losses as well. In PMFC also it has losses actually. It's having like sort of like activation losses, ohmic losses, and concentration losses. Take example of EV. You have actually the activation losses and ohmic losses. Why I'm saying these things, it's more or less if you understand battery, you can understand fuel cell. There is no much difference, because all these losses, materials used, slightly going to differ, otherwise technology is going to remain as it is. That's the reason it's like very important to understand what is the performance losses when you calculate or else, because as being an engineer, we try to model everything mathematically. So we try to build a mathematical model towards on this. So basically we estimate the activation losses, ohmic losses, and concentration losses. In similar in battery, activation and ohmic losses. Concentration losses, why it is added up here? Because you're feeding as a fuel. Their fuel, where it start diffusion process and all, it happens, right? There actually the concentration losses will occur. But in battery, you already store the energy and you're using it. That's the reason concentration losses will not come into picture. So this is very interesting graph. If you can just keep it for your long-term application or else long-term usage, that should be useful, because wherever you go, if you start explaining this thing, then you can easily fit into the EV or fuel cells. So because most preferably industries will try to, look into this particular aspects. And then if I say that actually the battery, the single cell voltage would be like 3.6 volt, maximum it go up to 3.8 volts. But in fuel cells, single cell voltage would be 1 volt actually. So when you draw the current, it will be coming up to 0.65 or 0.6 volts. Once you connect in series, it will add up the voltage. Once you connect in parallel, it will add up the current. So why I'm saying you this fundamental aspects, if you can just keep in your mind for long term, then you can easily understand and then brief into someone who are interested into the EV basically. That's the reason. Okay. Hope you got this performance curve, I feel. So because it's very important, I feel that actually you can use this performance curve in future also. That's the reason I thought at least you can just keep in your notes, or else the presentation is anyhow available. You can take the presentation as well. Okay. And then if I'm coming to the benefits and challenges, as I say that actually, when we are talking about like what are the benefits comparatively, because we talked about proton exchange membrane, alkaline fuel cells, phosphoric acid fuel cells. Comparatively, what are the other benefits? Basically, if you go to PMFC, it's having higher power densities. So it will give higher power density and suitable for especially automotive applications. That's the reason most people try to go towards an hydrogen PMFC technology. Other fuel cells, alkaline fuel cells, are used for electrolysis process to produce hydrogen actually. So you can imagine the same technology is used for vehicle, the same technology used for even green hydrogen production as well. There is no much difference actually. Only thing is you're reversing the process. There you're doing the electrolysis, here you're doing the fuel cells. That's it. That's the only difference. Otherwise, it's more or less same technology applies for hydrogen production, same technology applies for even producing, electricity in the vehicle as well. So this is a very important slide, just have a look at it. So due to time constraint, I'm not going to brief about completely on these things, okay? What are potential fuel cell applications? What we talked about, like what I'm started, like only transportation application? No, it's having multiple fold application. You can use it for even, nowadays you could see that the telecom towers, they use the DG sets, right? So they can replace that as well. Basically what happens, even fraction of second, it has to switch over to the DG. Otherwise it will have a sort of like a huge impact on the tower for you. That's the reason they switch over to the DG. But DG concern is the cost. Cost is too much high. So that's the reason people are moving towards on stationary fuel cells. So they're trying to replace. If you look at Ambani, more or less Geo towers are they're trying to replace with all this stationary fuel cells. So that's why I said that why someone want to interested in this technology, how it makes viable basically with the scale, as I say that. So that's where actually where Ambani and Adani is more interested towards on this technology because they have their own consumption as well. Not only external world, they have their own consumption. That's where it makes sense for them actually. And then if I talk about like, say it will go 100 watt to megawatt as well. So multi-fold applications. So basically it's having sort of like transportation, stationary, portable, and electric utility, especially even military as well, because for someone required in a cold climatic countries, cold, when you go to Kashmir or else somewhat in Jammu, they require heating basically, person who's there in military. So for them actually for heating application, even this small fuel cells are used. It's like some small box, similar to battery only, not much difference. Only thing is battery, you need to charge it. Electricity itself not available, right, for remote location. That's where they try to use hydrogen in terms of like say, in a solid storage format actually. Hope you, I think this will brief about on the application side. So finally, the hydrogen safety. Basically everyone talks about hydrogen is such a lighter gas and if it is leaks, what will happen? Because it's going to get huge impact, right? Because it's going to, because nowadays we are seeing every day some Ola bike is burning, right? So you can ask me that if hydrogen fuel cells comes, how it happens? Because every day transition cannot jump into the hydrogen IC engine to the EV. EV itself suffering too much. But in fuel cells, it is not going to happen anything because as I said that LFL limit and upper flammability limit, that range itself too wide. And when it's small leak also, no, the complete system is going to take a shutdown actually. You no need to worry about it. And also these are all like type 3 and type 4. Why I explained this storage cylinders, these are all composite cylinders. Even if you fire for bullets continuously, nothing will happen. That's the reason I said that when I started with a sort of like giving hints to the nothing too much worry about on especially hydrogen when you use as a fuel actually, comparatively batteries. Batteries concern us temperature, thermal runaway, because in India, temperature goes up to 45 and 50, but batteries has to be maintained less than 30 degrees centigrade. That battery management system will come into picture. That's quite expensive, and people try to do with an active cooling system where they use air or else water. But some people try to use in two-wheeler air cooling. That's very, because ambient air itself 45 degree. How can you cool in less than 25 degrees centigrade? It's common sense. Just I'm saying you just simple words. So that's the reason thermal management plays a crucial role as being a mechanical engineer or else control engineering or else electrical. It makes huge impact before going anything you should consider safety is a major concern first before launching into the any vehicle actually. So that's where I think we could see that a lot of EV vehicles are burning, especially in two-wheeler segments. Okay, so hydrogen, as I said, that hydrogen safety is much taken care in terms of like, as I said, that multiple things, you do the things because you store in composite cylinders itself, and also it's having sensors which will take care of all the activation and closing process actually. And then come to the potential applications in, especially in India, especially basically in India, especially we could see that IOCL floated a tender for hydrogen fuel cell buses. So 15 buses owned by Tata Motors, they supply the hydrogen fuel cell buses. And then NTPC floated a tender for hydrogen fuel cell buses. Basically, why they're floating hydrogen fuel cells? Because as I said that EV buses will not compete for a long distance vehicles. As I said that more than 200 kilometer, it not makes viable actually. That's the reason I think hydrogen fuel cells, and also everyone talking about on zero emission vehicle, carbon emission reduction, that's the reason hydrogen fuel cells makes impact. And as I said that long distance vehicle, trucks and goods, that's the reason I said that most of people are investing towards, why? Because they have their own consumption as well. Locomotives, yes, and something more or less trains also coming some application, but it's in very nascent stage actually. And stationary, lot of backup power application, especially for mobility. Say what I said that for telecom towers, and also for like supply for like emergency power supply for control rooms and other stuffs, and backup power applications. If you see real world applications, these are all the peoples who build the fuel cell vehicle, especially Toyota Mirai. As I said that one of the Nitin Gadkari sir has launched recently Toyota Mirai vehicle, so where you can public can use for that vehicle particularly. So similar way, Tata also built fuel cell buses in India. So they have 5 fuel cell buses running in Sanand plant. And also they're going to supply 15 fuel cell buses to IOCL. And also future NTPC is coming for the NTPC, as well as Kerala government is also floating tenders towards on this. Why this only in tenders? Because government is encouraging towards on greener technology, because someone has to push towards on something in initial level, right? So that's where we are getting a push from what you call actually government. And also I think now it's taken up by major or business icons, especially Adani and Ambani. So obviously they drive for this technology. So especially Nikola also is in fuel cell trucks, especially in US. And also Zero Avia has some sort of like flights applications as well. In summary, actually, just I'm going to summarize, then I'll leave it to you to ask some questions so that I can answer clearly. So fuel cell are highly efficient and also zero emission devices and quiet operation. There is no noise. You can just see that vehicles are running means there is no noise at all, similar to EV, because there is no moving components across the things. And it's modular in nature. You want to scale up for anything, it's possible. And wide operating range, it's starting from milliwatt to megawatt. You can use it for multiple applications. And also basically solution for sustainable electrical and heat energy sources, as I said, backup power applications. And India is also potentially considering green hydrogen production and usage as a fuel in this particular application. That's the reason I said that green hydrogen means via renewable energy, you are producing the hydrogen and then using that as a fuel in your vehicle. That's the reason it's called as green hydrogen. So, and then next is fuel cell applications are widening from automotive to stationary multi-fold applications, not into the only automotive. Why we are talking about today automotive? Because that's the more dominant market. That's where you are producing a lot of emission. That's the reason most of people talks about replace your conventional IC engine with electric vehicles, fuel cell electric vehicles. Well, that's the reason everyone talks on saying that move towards on energy sustainable technologies. And also especially hydrogen, especially National Hydrogen Mission is launched in 2021 to reduce oil imports and also to reduce especially CO2 emission part of it. In that note, I'll take a pass and thanks for listening my, especially the notes. I'll leave it to you, ask some questions so that I can answer a few questions. Thanks a lot. Thanks for giving me this opportunity. Yeah, done. They'll give, sorry, I just. Okay, till mic goes. I thought actually, I hope you got something at least out of this session. I feel. I don't know exactly because I don't.
So,
Yeah, please go ahead.
so as you said that hydrogen fuel cells are eco-friendly. So how can you conclude that they are eco-friendly? Because the material we are using to make them, they are milled in a factory which powered by the coal, and we are somewhere it has its own carbon footprint. So we can't say they are eco-friendly. And second thing is that as today we are discussing about the energy storage. So there are more high efficient energy storage are there in substitute of hydrogen fuel cells, such as lithium ion battery. If we see that it has an efficiency about 90 to 95%, and other alternative is flywheel energy storage. It has a efficiency about 85%. Then if we think about the efficiency of hydrogen fuel cells, it is only 60%. So how we can use that?
First of all, first question is like, as you said that lithium batteries are more efficient, right? Why you want to go? You tell me. So you want to depend on China? Today where you're getting from lithium. That's the reason India, especially we have water. Try to use that water. That's where actually everyone is putting footfall towards like what you have. You cannot compare yourself with some other countries, right? Someone has, obviously will promote his technology. India, as being we are Indian people, we should see what is available today with us. So, as I said that water is available and renewable energy sources are available. So obviously you must make use of it. I understand efficiency-wise, lithium-ion batteries are 95% and fuel cells are 60%, nowhere comparable. But you don't have it, what you do?
But India has a large water resource, so we can use pump storage facilities. They have 20% more efficiency than the
Pump?
hydrogen fuel cell.
How can I use it for vehicle?
No, that is not for vehicle, but we can use for grid.
Everyone is
storage.
trying for that actually. That's the reason. See, the thing is, yeah, if I'm going to talk about, see, this is only the technology is going to replace everything. No, it's going to complement. The technology is not going to replace suddenly IC engine. No, IC engines vehicles are going to be there. You cannot replace. Replace with percentage. 2%, 3%, that's fine because you're selling every month 5 lakh vehicle. In 5 lakh, 1%, if I say 5,000 vehicle, you can imagine. That's enough. So that you can contribute towards on green technologies. And also you said that eco-friendly, right? The first question was on eco-friendly. Obviously, because you're producing hydrogen via renewable energy. So as I said that, even I shown the gray hydrogen as well. So if you're producing via natural gases or else other gases, obviously it makes as a gray hydrogen, not the green hydrogen. That's the reason in COP26, India has pledged, say that actually we are going to produce green hydrogen at least 2030. That's the reason if you look at Ambani and Adani, they're investing 2030 as a target basically, where they commit with a very huge scale. Hope I answered your question or no? Still you feel?
I conclude that if you said that green hydrogen is not green, it has its own carbon footprint.
No,
You can't
no.
say it is
Green hydrogen is green if you use
No,
renewable energy.
Sir, if we think that we use solar panel as a green energy,
Correct.
somewhere it is made in a factory.
Right.
The factory is running on coal because solar panel needs silicon,
Correct.
aluminum, and
Correct.
the glass sheet that is on the top of that. The
Agree.
industry making that
Agree.
is not made by 100% renewable energy.
Agree with you.
That is made by coal. So how we can say that fuel cell is eco-friendly?
See, the thing is once, see, I understand what is your question basically. So I completely agree with you because industry once they produce, they make our pollution, means they leave the pollution, right? But actually that's not making huge impact comparatively what you're producing with other sources. If I use like fossil fuels or else natural gas, it produces huge amount of CO2. Basically, if I take a 1 liter of diesel or petrol, how much CO2 it produces? You are aware of it, right? So similarly, if I compare industries, it's not comparable actually. The scale is very high. So once you cannot compare with sort of like say with a high scale with a very, very low scale because you're producing sort of like 0.001% and then you're comparing with 100%. No, that doesn't make sense, right? Great, thanks. Thanks for your question. Nice to hear that actually. Thanks a lot. Thank you very much. Thanks for listening. Yeah, sure. Sure, madam. Please. Sure. I'll answer your question. Hello. Okay, no problem. Yes. Yes. On site. I'll tell you that as well. That's a good question.
Sir, my question is related to the weight.
Right.
How much is the payload created by the fuel cell if I wanted to use it on a vehicle when we compare with a EV? This is
EV basically will have a sort of like, say, if I take a bus example. So for 12-meter bus, simple I take because that's where city buses are running. It's easy for your imagination purpose. It's going to, for like 200-kilometer range, you have a 2-ton weight of battery. 2 ton of battery. Of lithium ion only I'm talking about, nothing else. 2 ton is 2000 kg. If I compare with a so normal conventional vehicle will have about like 500 kg, less than 500 kg because engine plus all the cooling system, all aggregates will come. That's the reason I said that 500 kg. Hydrogen fuel cells also about like 650 kgs for buses. So why I given this scale easy? Because you're traveling via city buses. That's the reason I wanted to quote easily so that you can relate with the weight. If you go for higher, what you call actually distance, again you need to increase the capacity of the battery. That's not possible because there is no space to package it actually. So you don't have space and also you don't have money to invest too much on the kilowatt hour batteries as well.
Sir, I'd like to ask one more question.
Please.
In a cell, you have written that the discharge is HO2. H2O.
Okay.
That is a water which
Water
is a
vapor,
discharge over
correct.
there. And you have written the word unused.
Yes.
So this water we can't use it again.
You-
So is it changing the property that we can't use it again over there?
No, you can use it. Normally what we do normally, we provide one flush button before going to, in other countries, whatever vehicles run now, we provide a flush button. You can flush the water nearby before stopping your vehicle. And then that water anyhow, you can use it for any application, not a problem. But that water anyhow is about like hardly 2-3 liter. What you will do with that water actually normally. That's the reason we provide a one flush button so that you can flush the water so that you can go to your home and keep. Because it's coming as a water vapor basically. Because once it crashes 100 degree, no, the water will become as a like sort of like mist sort of things. Obviously you cannot use it. Thanks, madam, for the question.
Sir, one last question of all interest of all of us. What is the future for my friends, students in India, nearest future in this segment?
I think there's a huge impact. If you look at the Reliance Industries, as I said, that 65,000 crores they're investing, and they're offering more than about like a, because I worked in Reliance as well. I know that's the reason. I worked in Tata Motors for fuel cells. That's the reason I worked in fuel cells only my entire tenure. And I worked in Reliance as well. And Adani also, they are investing. So basically we'll have a huge employment creation in terms of any engineer. Don't think that as a mechanical engineer or else ENC or else what you call computer science will not make into this particular field. No, this field has everything. It's having chemical reaction, it's having electrical connections, and also it's having programming skills as a like controller part of it, and also a mechanical engineer can design everything as a sort of like complete whole package. So this makes huge impact in terms of you're planning to create your own career in terms of fuel cells. Obviously, if you know some basics, anyone can just take you, because one day we are discussing in sort of like in the hiring process basically. Someone says fuel cell, we'll hire them. Like that it's situation in India because people don't know word itself, fuel cell. They have not heard about it. Again, training on that, it's like someone knows something part of at least initial understanding. So hand-holding will be easy. If you don't know even word, then it's very difficult to explain and then bring into that particular technology because person is not interested, then you are dumping into that particular understanding quite difficult actually. That's the reason I said that understand some basics, not even like application or else usage point of view. If you know clearly some words, understand and then try to put your basic understanding or else basic mathematical model, because lot of you are watching lot of internet channels. If you put hydrogen fuel cells, lot of videos is going to come actually. So if you watch that, That's enough actually. So, yeah,
Okay, thank you.
thanks a lot. I think,
Sir,
yeah.
One question.
Sorry, yeah. Ah,
Sir.
yeah, please go ahead.
Sir, as this technology is successful but not economically viable,
Correct.
so how long it will take to make this technology economical viable?
Oh, that's a good question actually. So what we do, we call it as TCO, total cost of ownership we calculate for any technology once it's coming as a break-even analysis. So this technology, if you go with a sort of like say, if you replace 5% of the vehicle in India, it's going to make viable, equal to more or less I can say diesel IC vehicles. 5%, I'm not talking about 100% replacement. 5% replace with hydrogen fuel cell, it's make it viable equal to diesel vehicles. That's the reason I said that why Reliance is investing in this, because they own their consumption. They don't want to sell to you. You are not buying, that's, they are not bothered much because they have 200 vehicles every day consumption in their petrochemicals. That's the reason they produce hydrogen fuel cell vehicles. They consume it, they produce hydrogen, they use it. So that's why I said 5% it makes your TCO is viable, especially in transportation segment.
Thank you, sir.
Thanks a lot. I think on the desk I have a question, basically. How does it makes on-site hydrogen generation or off-site hydrogen generation? So that's the question asked by sir actually. So on-site hydrogen production is more or less a bit costlier because you're going to produce on-site itself. What Reliance or else some other companies are thinking is like hub and spoke model. Hub and spoke model is nothing but they produce hydrogen in off-site and they keep it as a surrounding, like say 300 kilometer circle. So they transport it. So that hub and spoke model means they have a complete circle. They create similar way offsite production so that they have a complete offsite production of hydrogen. That's called hub and spoke model. They produce hydrogen in offsite and then they send it to the particular nearest by area so that they can easily reduce the transportation cost. Basically, why? Because other fuels will have a sort of like pipelines and everything. Today, hydrogen do not have a pipelines. So, and also refilling stations. So that's where actually it's lagging. So as I said that EV also struggling with the infrastructure part. So similar way, this also struggling with the infrastructure part. So offsite production makes economically viable because we have done good amount of calculation on that, on-site or else off-site. Off-site will work out, as I said that, hub and spoke model. Thanks, sir, for this question. Yeah, any last question? Yeah. Sorry, I'm taking too much time. Sorry for that, actually.
So as you say that one single cell produces 0.6 voltage. So
1 volt, yeah. 1 volt is open circuit voltage, yeah.
Yes, sir. For 12 volts, we need to assemble
12
20 cells for in series. So still again we are facing storage and arrangement problems because after that it getting more heavy. After that it becomes more heavier and getting more weight. So how we can solve it?
Actually, I was not. I think if you have some time, come and see I bought one plate for this thing. You can see that it's 0.1 mm thin plate. It's do not basically 100 kilowatt system will have 100 kg weight. You can imagine 100 kilowatt will have 100 kg weight because it's made up of thin foil, kind of 0.1 mm material. So it will be hydroformed or else stamped, the metallic plates. Or else second source is basically graphite. That's also about like 0.2 mm thickness, and it's having completely, when you assemble 400 cells or something, because 100 kilowatt 400 cells are required, will have 100 kg. That's it. Comparatively, engine weighs about like say 100 kilowatt, about 250 kgs.
Yes, sir. Thank you.
Thanks. All right. Yeah.
Sir.
Okay. Due to time constraint, I'll take 2-3 questions. I hope. Sorry for that, actually.
Sir, when it comes to combustion fuel, when talking about mobility, combustion using vehicles, they use basically petroleum type, diesel petrol. So we need to depend on Middle East countries for the fuel.
Correct.
So the price depends on them.
Correct.
But when it comes to EV vehicles, they use batteries.
Correct.
But still for the production of batteries, we need to dependent on the silicon manufacturing.
Yes.
Like we need to depend on China for that. Does hydrogen fuel cell use batteries?
No, hydrogen fuel cells don't use battery. We use small capacity battery to address only the startup part of it. Otherwise, it do not require any battery basically.
So can we say that after 2030, after the research work is done, will India be independent for producing and running its own hydrogen?
That's the target. That's the reason everyone could see that everyone is presenting towards on that 2030 20 basically if you look at national hydrogen mission 15th August Narendra Modi presented, you want actually the at least 2030 is sort of like where you can engage with sort of like all this alternative fuels. Basically it's a substitute, and also it's going to complement to the earlier technology. As I said, that is not going to replace entire your transportation sector. It's huge, it's impossible. You cannot do that. Over the period it happens, but at the moment to start off with, it start with 1%, 1.5% like that. That's itself sufficient actually.
Sir, can
Okay, yeah, sure. I think you can ask me question in off the desk, so that would be good as well. I think for
Thank you, sir.
as time is limit, and thanks for giving me this opportunity, and then thanks a lot. Yeah.
That was a nice lecture. And I think we have learned quite a lot with this. There was one or two questions I would just like to answer a little bit quickly. Somebody asked about the question of cost of hydrogen. The cost of hydrogen, they consider at anything below $1.5 per kg as an economical price. And we are expecting the price to go down that within a very short time now, and very much in India. The second question was about the efficiency. People are harping about the efficiency quite a bit on fuel cells, but one thing they forget, the energy available is absolutely free. And what you are using is water and putting back into water. So you are taking water from the nature, returning water to the nature. In the meantime, you are using energy from the renewable sunlight or the wind, so that makes no difference at all. Ultimately, we are concerned with the cost factor, of cost of utilization. And where that cost of utilization is absolutely within control and economical, the efficiency will not be much of a concern. I should thank Mr. Dr. for the nice lecture, and this will be the end of this session. Anyway, I'll hand over to the people.
Thank you, sir, for your words of wisdom and thought-provoking and brainstorming address.
Sir, we will be in touch with you in future for the guidance. If you have more questions regarding the hydrogen fuel cells, give your questions to respective faculty. We will collectively submit that questions to the Mr. Yogesha, sir.
Now we will have a lunch break of 30 minutes, and we will once again assemble over here for the next session, and the next session is connecting from the Germany. And the venue is Dental Auditorium, 2:30. We have to assemble over here at 2:30. And the venue is Dental Auditorium and Engineering A building, A108. Only those who have coupons for lunch.
Yes.
Thank you.
Thank you so much.
So dear students, at 2:30 we will gather back over here in auditorium.